Good morning and welcome to this new video. This video stemmed from the discussion with one of my former students who said that the design force has increased so much with the new code with respect to the previous code of IS 1893. This perception is valid because the zone factor has changed so much. Earlier the highest zone factor was 0.36, whereas in the present case the zone factor highest is more than 1. Even in the corresponding zones, the zone factors are much different, much higher in the present code. However, telling the design force how many fold higher in the new code is not so a straightforward answer, because so many factors are involved there and all the factors you have to take into account to get a conclusion. This video will be aiming to give a rough idea about the increase of magnitude of the design force in IS 1893-2025 with respect to that of IS 1893-2016. So with this introduction, let us go inside the video proper, where I shall be taking a building in a particular location and then we shall find out the design forces with respect to both the codes and compare them. Yes, so comparing the design forces in the old and new code, IS 1893, 2025 and 2016. For this purpose, we consider a building. Let us consider a building at certain location. We have considered a building at Silchar. Silchar is a city in Assam, the second largest city in Assam, which was in zone 5 in the previous code, and in the present code it is in zone 6. We take the type of the building as critical building, critical important building, and it is reinforced concrete, special moment resistant frame building. This is the category of the building. Let us take, for the sake of our numerical example, the time period of the building is 1 second in the horizontal translatory motion. The soil, we consider the foundation as hard soil as per IS 1893-2016 and soil class A or B as per IS 1893-2025. Return period also you have to consider, because the zone factors in the new code are given in terms of return period. For seismic zone 5 or other code zones also, the return period was not specifically mentioned in the previous code. However, for MC level, which is 2% chance of accidents in 50 years, the Google search gives you return period 2475 years. So we shall be using this return period for our calculation purpose. Now let us take the horizontal seismic acceleration as per equivalent static method given in IS 1890-2016 part 1. Our building has a time period 1 second, so it is falling in this part, 0.4 second to 4 second. So this is where we are lying, and the expression for spectral acceleration is given by 1 by t. So t is 1 second, so SA by g is 1 by t is equal to 1. In the new code, in the equivalent static method, 1 second lies in this range, 0.4 second to 6 second. So here also the spectral acceleration ratio, normalized spectral acceleration ratio at 5% damping is given by 1 by time periods. So it is again t equal to 1 second, so ANH equal to 1 by TH equal to 1 by 1 equal to 1.0. So our spectral acceleration ratio is 1.0 in both the cases. Now let us take the response spectrum method. In response spectrum method of the previous code, 1 second time period lies in this range, and again the spectral acceleration ratio is given by 1 by time period. Similarly, in the new code, 1 second lies in this zone, 0.4 second to 6 second, and the normalized spectral acceleration ratio is given again 1 by time period. So whether you take equivalent static method or response spectrum method, for our building we have considered the spectral acceleration ratio is 1.0. Now let us take the importance factor. For critical building, importance factor is 1.5 in the previous code. So we shall take this I equal to 1.5. In the new code, a critical building is here where importance factor is 1.0. This is taken from IS 1893-2025 part 5 that deals on buildings. In fact, for all kinds of buildings, importance factor in the new code is 1.0. So I equal to 1.0 here. Now let us take the elastic force reduction factor. It was called as response reduction factor in the previous code. In both the codes, the symbol is given as R. We have taken RC SMRF building, so it is 5 here. So R equal to 5 in the previous code. In the new code also, RC building with special moment resisting frames with ductile detailing as per IS 13920, it is 5. So R equal to 5 in both the cases. Now let us see the seismic zone factor, where you have the typical changes made from the previous code to the new code. In the previous code, Silchar is in zone 5, so the zone factor was 0.36. This 0.36, and how do we correspond to this case and the new case? We correspond it through the return period. Return period we have seen it was 2475 years. So we are in seismic zone 6. Silchar city is in seismic zone 6 in the new code, and return period is 2475 for the building considered. So it is 0.75. Zone factor is 0.75. So Z equal 0.36 in the previous code, and Z equal to 0.75 in the new code. Now let us apply the whole knowledge in the base shear expression. In the previous code, the base shear expression was given by Z by 2, I by R, SA by GW. In new code, it is written as BBDH, B for base, D for design, H for horizontal, Z I by R, ANH, TH, W. Out of this, the spectral acceleration ratio is 1, we have seen, or ANH is 1, we have already seen the previous slides. Let us come to this case now. BB will put all the values. Z equal to 0.36 divided by 2. This 2 is used for design basis earthquake computation. Importance factor is 1.5, R is 5, and SA by G is 1, W. So BB equal to 0.054 W. In this second case, you see the Z equal to 0.75, I is 1, R is 5, and the spectral acceleration ratio is 1. So this is the expression. It comes as 0.15 W. So now if you take the ratio of these two, base shear force per new code and base shear force per previous code, then you get 0.15 by 0.05, which is 2.78. So apparently you see the design force in the new code is coming as 2.78 times the previous code. But something more is still missing. Let us see. The load combination effect also has some bearing on this computation. The load combination effect also has some bearing on this computation. In the previous code, load combination was 1.2 dead load plus live load plus earthquake load, or 1.5 dead load plus earthquake load. So earthquake load was multiplied by the partial safety factor in the previous code. In the new code, the earthquake load you can see here is not multiplied by any partial safety factor. So this will make a difference now. So this BBDH by BB now will be 2.78 by 1.2 in this case, which is 2.32, or it will come as BBDH by BB equal to 2.78 by 1.5 in this combination, which is 1.85. So your ratio of the design force in the new code and the previous code comes roughly as about 2.32 is near 2 and 1.85 also near to 2. So almost twofold increase in the design force is visible in the new code with respect to the previous code. Now in all buildings it may not happen so, because building to building variability will come, importance factor may change in the previous code, zone factor values, return period, etc. may change, and this may change slightly in the case to case basis. However, that it has increased to about twofold is very clear from our discussion. Thank you very much for coming up to the end with this video. I wish you subscribe to this channel, like, share and view the videos, and put your comments in the comment box, your queries. I shall not only be glad to answer your queries, but also it shall enrich my knowledge, because I have to read further to answer your queries. Thank you.